Good day, students. Good day, fellows. Here comes again elevated excellent language. Though this is our first lesson in the channel. So today we are going to be having physics on the topic measurement. And what we're treating on measurements today is dimensions and unit. Dimensions and unit. So what are the objectives of this session? The students must have the basic understandings of fundamental and derived quantities. They must be able to identify the SI units of the fundamental quantities. They must be able to derive the dimensions of the derived quantities. So now let's look at what the fundamental quantities are. The fundamental quantities are the basic quantities that are independent of other quantities and cannot be derived from them, which implies that they are independent of other quantities. They are the basic quantities of physics, and examples are the length, time, mass. Sorry, they should be an S here. The length, time, mass, electric current, it should be double S, electric currents, etc. These are fundamental quantities, but these are not all the fundamental quantities we have in physics. There are about 7 fundamental quantities in physics. So now let's move to what derived quantities are. Derived quantities are those obtained from the simple combination of fundamental quantities. They're the ones that are obtained when we combine fundamental quantities together. And examples are area, density, volume, pressure, momentum, etc. These ones are formed from fundamental quantities. Let's understand them better. So now let's look at these fundamental quantities. We have about 7 fundamental quantities here and their units. And you should also note these units listed on the right side here are known as, or the unit is known as the SI unit, the System A International Unit. Let me write that down on the board here. The System A, okay, the System A. Let me enlarge. Allow me enlarge the box vertically and horizontally. So this System A International National Unit. So it is what S S I unit. SI unit, which is the Systemic International Unit. So this unit here is the Systemic International Unit. The Systemic International Unit is the unit that is generally acceptable in the world today. As we all know, measurement is a very important aspect of physics. No fact in physics is acceptable unless it's quantified, it is measured. So the units at the right side here are the Systemic International Unit of the fundamental quantities here. So one of the fundamental quantities that are listed here, we have the length, mass, time, electric current, temperature, unit of substance, luminous intensity. And what are the units of these quantities? We have the meter for the length, kilogram for mass, second for time, ampere for electric current, Kelvin for temperature, mole for amount of substance, kilogram for luminous intensity. So what we're not looking at this yet, but let's get to the theoretical aspect of the class. So now, as we said earlier, it stated that fundamental quantities are the quantities that are independent of other quantities. The remaining quantities are derived from them. So let's take a look at this. Okay, now we have length. Length here as the fundamental quantity, mass, and time. So now, before you proceed, you should also know that there are three most important basic quantities. Three most important basic quantities in physics, which are what this year: the length, mass, and time. They are the most important basic quantities in physics. You get to see that here, that they are among the fundamental quantities. So among the fundamental quantities, we now have 3 quantities that are very important. So when we now move to this, how we can write dimensional formulas? We are writing dimensional formulas by making reference to the most important basic quantities. So let's look at this now. Examples. Okay. Once again, I stated that there are 3 most important basic quantities in physics, which are the length, mass, and time. And when we are working on the dimensional formula of the derived quantities, we are going to be making references to these quantities here. So let me erase this now. And now, example 1, we have area here. And note, you can only find dimensional formula of derived quantities only, Neither can we find, or we can't find the dimensional formula of fundamental quantities. So let's begin with the first quantity here, area. Area. So what is the relation with the other physical quantities? Is what the formula is, and the relation we are saying we are working with the relation, which will also be referred to as the formula. So the relation with the other fundamental quantities is what length times breadth. So now the relation with the other quantities is length times weight, which is the formula. So how do we now get the dimensional formula of this quantity? What do we do? And like I said earlier, the basic important quantities in physics are going to be our reference point. So let me write this out. So length, mass, and time. So now, when we know that, okay, and the length you can see the symbol to represent the quantity length is L, for mass is what L, and T time. That's what I'm going to use, which is what that is generally used. So, which in the area is less than breadth, we have the symbol for length is L, and for breadth, so L multiplied by half of breadth. You also note that when we're talking about breadth, these two um, these two quantities are also length. They also refer to as length because it's also the distance covered by 100, so it's also length. So what we do? Get this by what? L times L, which is what? L square. So now we're going to get the dimensional formula of the area. So now, and I also told you, I stated earlier that the dimensional formula will be based on these the three basic quantities in physics. So what do we do? We need to find a way to include the mass and time here. What do we do? We say what? Then m l squared m t. Can't just take like we have to include zero to refer m is per zero as one, and t is per zero as one, so that L2 this will also be equal to what? This m is per zero, which is one, 2 is per zero, which is one, equal to this. We are going to obtain the dimensional formula of area using that. So here it is L0, L2, T0. So let's move to the next example, which is volume. So for volume, what is the relationship? What is its relationship with other quantity? We have what? Length times breadth times height. Length times breadth and height. And we know length, which could be L. When we take it back here, L. And so the breadth is also the length, height is also length. So we get what? What do we get? L times L, which will give L cube. And so we have to include the remaining fundamental quantities, then MQ, LQ, um, 0, then T, sorry for that, then T0. That's it. So now let's move to an advanced one. So now, let's determine the quantity, the dimensional formula of density. What do we do? Density. What is the formula? You need to get its relationship with the other quantities first. So which is mass over volume. Or let me expand this. Mass over volume. So as you know, among the three basic quantities, mass stands for mass. So write mass over volume. And like we did earlier, we said volume is the formula for volume is length as well times height, and we got its dimensional formula as what? L cube. So that's what we're going to write here. So you should not forget that, which is what? L cube. So let me write the cube here. L cube. And you see, so you must ensure the dimensional formula is in what? You must ensure the dimensional formula contains only the basic quantities, which is the length, mass, and time. Dimensional formula. So, so here it is your MQ. So what's next? What do you have next? You say what? M over L cube could also be, where is this item? Okay, here it is. It could also be M times multiplied by 1 over L cube. 1 over L cube. It could also be this. Then what will be then M L this power minus 3 ML is minus 3 So here is the dimensional formula, but we need to include the remaining quantity, which is time. Then square t raised to power 0. Here it is. We are going to obtain the dimensional formula of density. Okay, so what we're going to give one more example, and um, we are going to I'm going to give you classwork and I'm showing you the solution. Okay, let's proceed with that. So let's solve for velocity, which is displacement over time, or which is solve for acceleration. Let's solve for velocity first. So how do we do that? So you say what now? Okay, here it is. Velocity, which is equal to displacement over time, right? And now let's obtain the dimensional formula, and displacement will also be length because it's the distance covered over what time. And as I said earlier, basic quantities which are going to be our reference points, uh, length plus and time. So t, then this could also be what L divided by t could be what L times 1 over t, which should give what L t minus what minus 1. You can include the m to it for it to be completely done, then m is equals 0. So now if you have to determine the dimensional formula of acceleration, how do you do that? So let's check it out here. Sorry, it's not responding. Okay, okay, for acceleration now. Acceleration, let me expand this. Is what velocity. You need to understand the formula over time. Then for velocity, what is the dimensional formula? We have lt. We have what? We have lt minus 1 already. We don't need to include m goes for 0 because it was an extraneous item. Mt is for minus 1. Then over what? Time. This t, the time here, the one here, so over time. Then you have to simplify it. How do you simplify? This will be L times what? 2 raised to power minus 1. And using the laws of physics to get this right, I'll be treating the top commands which you are treating the top commands which should be indices so that we'll be able to solve questions like this correctly. But that will be dropped later. So L times T raised to power minus 1 divided by T raised to power minus 1 divided by T. And as we all know, length of indices should be L times what? T raised to power minus 1 minus what? 1. I'm sorry, it's not clear. Okay. Then L T what? Minus 2. Correct. You are able to obtain dimensional formula of acceleration, but we only need to include the m. Note this should be in order. Then m, l, t, n first before l. Then is for 0. 0 must be included. So that's it. So attempt this. So you are advised to pause the video, then answer the questions. After that, yeah, this is the answer. So meet yourself. Thanks for watching. Do not forget to subscribe and share. Await next videos. Thank you very much.